In this experiment, we attempt to find the moment of inertia of a wheel by rolling it up an inclined plane. We know that the total energy contained in the system, or delta E of the system, is composed of two primary components: the delta E of the linear momentum and the delta E of the angular momentum. We can equate the total delta E of the system to the gravitational potential energy of the system using delta E equals mgh. By finding the distance that the wheel has rolled, we can find the height that the wheel has reached. Because we did not have a device that we could use to measure the angle of the slope, we used math to calculate the slope in degrees. Knowing that the platform was 190 feet long and had a 9-foot rise in elevation, we could find that the approximate slope was 3 degrees. Initially, we attempted to start the wheel rolling first, and then place it on the ground, allowing its angular momentum to carry it forward. But in this instance, most of the energy was lost to heat. The next method that we tried proved too hard to aim so that the wheel would go straight up the ramp. Finally, we found that accelerating the wheel on the ground from a standstill was the best way to ensure accurate results. We then used tracker in order to find the initial velocity of the wheel before going up the slope. We conducted multiple trials, recording both the velocity and the distance in order to ensure accurate results. When we plugged in our collected data into our formulas, we found a coefficient of 0.25, which is significantly less than the 0.75 that we expected from a wheel of this shape. We estimate that the biggest sources of air in this experiment are air friction and rolling friction of the wheel, which were not accounted for, and measuring inaccuracies in our estimation of the wheel speed using tracker, and measuring limitations in our prediction of our slope, and our measuring to the nearest inch in distance.